All right, 6-1, Intro to Trigonometry. So a couple things we have to know here. You should have covered it in geometry, but there are some new terms, or maybe they just changed the terms. But looking at this one, we have angles. Okay, we should know what an angle is. When you have two rays that meet at a vertex, that makes an angle. So if I'm looking at this diagram, this little pink line is my angle. Okay, and I have an initial side, which is right here in blue. This is my initial side. This is where I'm starting. And then I'm going to my terminal side. Okay, that's considered the position after rotation. Okay, and like I said, this endpoint right here is considered my vertex. So just a couple key words, key terms that we should know. All right, looking at this, we have angles on coordinate planes. Okay, we should know what a coordinate plane is. So if I'm looking at this coordinate plane, this is my coordinate plane. You have your X and Y coordinates. Okay, this is an angle in standard position. So that means I'm starting at my initial start or my initial side, and then I'm taking that arrow and I'm moving to my terminal side. Now this is going in the, I know it may look like the negative direction. It's positive because think about it, it's going up. I'm initially starting up. So now when angles are in positive or negative form, okay, when I have a positive angle or a negative angle, it's, all right, so counterclockwise, clockwise depends on if the angle is positive or negative. So if you're looking at it, this diagram right here is super important for you to remember. So I'm starting at my initial side, which is right here in blue. Think of it as my 0. Okay, this is my 0 side. So that's my initial side. The angle for that line is going to be 0. Now if I'm finding a positive angle, that means I'm going counterclockwise. Think about it. I'm starting at that initial side and I'm going up. Okay, think of up as the positive direction. This is a positive angle, depends on where I'm stopping. Now, if I'm going in the negative direction, I'm going to be going down. This is negative. This means I'm going clockwise. You have to remember, if they're asking you to sketch the angle, you can get angles that are both positive and negative, but now you have to determine which direction am I going. So positive goes counterclockwise, negative goes clockwise, and I'm going to show you that in the examples. So please make sure you understand this. All right, now measures of angles in degrees. Okay, the amount of rotation from the initial side to the terminal side determines the measure of an angle. So we should understand how to find angles. Okay, theta is another form of saying angle, and when you see that, that is this little symbol right here, the circle with the slash. That's theta, okay? So initial side, where we started, okay, this is my initial. If they're asking me to sketch something that's, let's say, 45 degrees, okay, 45 is a positive angle, so it's going to be in quadrant 1. Okay, you have 4 quadrants on a graph, on a coordinate plane. This is my coordinate plane, okay? How do I know where the quadrants are and what goes where? Think of your quadrants as, let's say, Miss Chung, the letter C. So when you're writing a C, you're starting at quadrant 1, you're going to quadrant 2, quadrant 3, and then quadrant 4. So that's just basic things we should know, okay? Where our quadrants are located. Now, what are the measurements within those quadrants? We know that right now, this makes a 90-degree angle. Each quadrant is 90 degrees. So if I have a 90-degree angle right here, you could think of it as adding another 90. Also think of this as a straight line, and the straight line in geometry is 180 degrees. Okay, so right now I have 90, I have 180. If I were to add another 90, that would give me 270 in quadrant 3, so that's from 180 to 270. And then going all the way over to quadrant 4, adding another 90 would give me 360. A full circle is 360 degrees. So again, if they're asking for you to sketch something that's 45 degrees, doesn't have to be perfect, but I do have to see what direction you're going in. So because it's a positive 45, you have to show me the arrows going in the positive direction for my angle. Now if they said, okay, sketch something that's 170. I know that's in quadrant 2 because that's in between 90 and 180. So I'm going to go ahead and just, again, doesn't have to be perfect, but I do have to see that you're starting at that initial side and you're going in the positive direction for my angle. Okay, and same thing for all of these. Again, if they ask, okay, sketch 200 degrees. Maybe this isn't 200 degrees, but I do, again, need to see that you're going in that positive direction. And sketch something that's 300 degrees. Again, just drawing that line and then drawing that it's going over here. Now, if they said, okay, give me something that is negative 45. If they asked for negative 45, I'm going down. Okay, I know that's in between 0 and 90. Again, this is 90 degrees. I'm going negative 45. So I'm going in the negative direction. Okay, negative is clockwise, positive is counterclockwise. So that's something that you have to know. I know it looks like a bunch of different lines, but you have to know 90 degrees at each. It does not have to be perfect, but I have to see those arrows. So in the next few examples on the next slide, we're going to go ahead and sketch them, and you'll see it without so many different things all over it. So these examples say sketch the following angles in standard position. So going ahead and looking at the first one, 61. I'm going to go ahead and sketch my coordinate. Okay, just a super easy, basic. I have my X, I have my Y. And where would 61 degrees fall in? Quadrant 1, okay? Quadrant 1 is from 0 degrees to 90 degrees. So again, like I said, it does not have to be perfect at 61. All I need to see is that you're starting at that initial side and you're going in the positive direction to 61. That's it. Now looking at number 2, doing the same thing, I'm going to go ahead and just sketch that graph. I have X and Y. Here's my X-axis, here's my Y-axis. Where would negative 3 be? Okay, where would negative 3 be? It's negative, so which direction am I going in? I'm going clockwise, okay? So this is 0. This would be negative 90, negative 180, negative 270, and then going back around would be negative 360. So 30 falls in between 0 and negative 90. I'm just going to go ahead and draw that arrow. This is my initial, and I'm going clockwise. So this is what negative 30 would look like if I had to sketch it. All right, going ahead to number 3. Now, 405. 405 is more than 360. Is it a positive 405? Yes. So now what is this one going to look like? I have 0, I have 90, I have 180. These are all degrees. I have 270, and then back to 360. Now if I added 90 to 360, I'm going to get 450. So I know that 405 is going to be in between 360 and 405. Now what is that going to look like? I'm starting at my initial side, and then I am going to go ahead and I'm going to go around past 360 to somewhere in between 360 and 450. Okay, so this is now what it should look like. Yes, I did a swirl because I'm going past 360 and I'm stopping somewhere in between 360 and 450. Looking at number 4. Now this is negative. Have to go in the negative direction. Please make sure you remember. If you're going in the negative direction, you're going clockwise. So draw your graph. Guys, anytime it says sketch and the graph isn't given, you still have to give your graph. So here's my x, here's my y. I'm starting at my initial side at 0. And if I'm going negative, I'm going clockwise. So this would be negative 90 degrees. This would be negative 180 degrees. And I know 120 is in between 90 and 180. And drawing my arrow. Please make sure your arrows are drawn correctly, because when we are sketching, we are going to check for that. All right, looking at the next ones, coterminal angles. So when we're finding coterminal angles, depending on how they're giving it to me, you have to either add or subtract 360 degrees. Okay, so why do I mean it depends on how they're giving it to me? Now, we're going to see examples where it's given to you in radians. Okay, so depends on what they're giving you as your angle. You're going to either have to add or subtract 360 degrees. Okay, so if they're asking for a positive coterminal angle, you're going to add 360 until you get a positive number. If they're asking you for a negative coterminal, you have to subtract 360 until you get a negative number. And you're going to see that in some of the examples on the next slide. So it says find a positive and negative coterminal angle for the following angles. So you have to do both, positive and negative. So looking at this, because these are in degrees, okay, 55 degrees, negative 30 degrees, 405 degrees, negative 629 degrees, I'm either adding or subtracting 360. Okay, find the positive and negative coterminal angles for the following angles. So I have to do it twice. Okay, so for positive, I'm going to add 360. And then for negative, I'm going to subtract 360. So yes, I have to have two answers. So if I'm adding 360 to 55 or 55 to 360, I'm going to get 415. And that's my positive coterminal angle. Now, if I have to subtract, I'm going to get negative 305. So I have both a positive and negative coterminal angle. These would both be my answer. You have to have positive and negative. All right, now looking at the next one, number 6. Again, they're asking for positive, meaning I'm going to add 360. And with that negative coterminal, I'm going to go ahead and subtract 360. So adding and subtracting, if I do 30 plus 360, I'm going to end up with 330 degrees. And then if I'm subtracting, I'm going to get negative 390 degrees. So I have a positive and a negative answer. I'm done. Please make sure you're adding those degree signs. If not, you will get points off. So please make sure you have the degree sign. All right, going to number 7. Please pay attention to this one. I will go back up if you need it. All right, looking at number 7. Same thing. I'm still finding a positive and negative. Positive means I'm going to add 360. Now, adding 360, I'm going to get 765. So super easy. 765 degrees. That is my answer for my positive coterminal. Now, I need a negative coterminal. I have 405. And if I were to subtract 360, I'm going to get 45 degrees. Is that a negative coterminal angle? No. So that is not my answer. I have to go one more step further. I'm going to take that 45 degrees and I'm going to, again, subtract 360. Now, if I subtract 360, I'm going to get negative 315. Is that a negative angle? Yes, then that would be my answer. So when you're trying to find positive and negative, you have to have a positive and you have to have a negative. So I'm just going to write it on here because this is not a negative. Subtract again. You have to have a negative. All right, going ahead and looking at number 8. Same thing here, following the same steps. I need a positive, so I'm going to add 360. If I add 360, I'm still going to have a negative number. 269. So I have to go ahead and add one more time. I'm going to take that negative 269 and I'm going to add 360. If I add, I'm going to end up with 91 degrees, which would be my answer for this one. This is a positive coterminal angle. Now I'm going to go ahead and do the same thing, but now I'm going to subtract negative 629 minus 360. If I subtract correctly, you're going to get negative 989. And because that is negative, that is my answer for my negative coterminal angle. So please make sure you are solving these correctly. Again, you need both a positive and a negative coterminal angle. So make sure you're going all the way to something that's positive and all the way to something that's negative. Keep in mind these are in degrees. Okay, in the next few examples, you're going to see ones that are in radians, and you're still finding positive and negative. All right, measures of angles could also be written as radians. Okay, 1 radian is the measure of a central angle. Okay, so this is my central angle, theta. Okay, and 1 radian is the radius. So if this radius is here, this is the measure of 1 radius. So if I'm looking at the diagram, you have your radians there. Okay, so if I'm looking at it, here are my radians, and these are the measures of the radius starting from the initial point. So this is 1 radius, 2 radius, 3 radius, and whatever's left over here is about 0.1415 radians as decimals. But you really have to know 1 revolution around a circle of radians corresponds to an angle of 2 pi radians. So if I'm looking at this diagram, 1 circle starting from here all the way around is 2 pi radians. Okay, because think of it, what's the measurement of pi? Okay, 3.1415. Okay, so if I'm looking at it, if I have 3 radians right here, this is 3 radians and 0.1415. Okay, so this right here is 3 pi. Okay, not 3 pi, it's 3.1415, which is pi. And if I have a full circle, that gives me 2 pi. This entire circle is 2 pi if I go around once. So that's something you have to understand, okay? So we're going to be doing the same things we did before, okay? It says coterminal angles. We're still using coterminal angles, but now we're dealing with radians. So instead of adding and subtracting 360, 360 is the same thing as 2 pi. So now we're adding and subtracting 2 pi. Okay, you have to know the difference between degrees and you have to know the difference between radians. So these are radians. Clearly they look different than degrees. And if they're asking me for, again, positive and negative coterminal angles for the following angles, same instructions. But again, I'm not using 360, I'm using 2 pi. So going ahead and doing the examples for these, I'm going to go ahead and look at number 9. Again, I need both positive and negative coterminal angles. So I'm going to add 2 pi. What do I have to do when I'm adding a fraction? What's the most? Okay, I put it over 1, but what else do I have to have when I'm adding fractions? I have to have a common denominator. And what would my common denominator be here? So that means I have to multiply top and bottom by 6. So I'm just going to go ahead and rewrite it. I have 17 pi over 6 plus 12 pi over 6. Solving this, all you have to do is add. Okay, what's 17 plus 12? I'm going to get 29 pi over 6, and that would be my answer. Keep in mind they want both positive and negative, so because this is positive, I'm going to go ahead and now I'm going to subtract. So I have 17 pi over 6 minus 2 pi over 1. Multiply top and bottom by 6. If you wanted to already just plug it in as 12 pi over 6, you could have done that. But just showing my work, I'm now going to have 12 pi over 6. And what would I get? Okay, 5 pi over 6, perfect. But is that negative? No, so what do I have to do again? Good, I'm going to subtract again. But because I already know that I have to find that common denominator, I'm going to just go ahead and use 12 pi over 6. Okay, if you want to do it again, 2 pi over 1, don't forget you still have to change that denominator. So now subtracting, if you subtract it correctly, you're going to get negative 7 pi over 6. And because this is negative, I have my answer. Okay, so just remember that you have to have both positive and negative coterminal angles, and you have to get that negative. Same thing with the positive, you have to get a positive. So let's go ahead and do example number 10. Because it's in radians, I'm going to go ahead and I'm going to add 2 pi over 1. Have to get that common denominator, so I'm multiplying both sides by 3. I have negative 4 pi over 3 plus 6 pi over 3. Keep in mind, don't forget that negative sign right here. So it's negative 4 plus 6. I'm going to get 2 pi over 3, and it is positive. This would be my positive coterminal. Okay, now I'm going to go ahead and find that negative. I'm going to have negative 4x, or not 4x, 4 pi over 3, and now I'm going to subtract. Again, since you already changed the top one, I can just write it as 6 pi over 3. Instead of writing it as 2 pi over 1, then multiplying by 3, I already know that it's 6 pi over 3. And if I solve this one correctly, it's going to be negative 10 pi over 3. And again, that is negative, so this would be my answer. So don't forget, these are written in radians. And when it's written in radians, you have to use 2 pi. So when it asks for positive and negative coterminal angles, you have to determine, is it in radians or is it in degrees to determine what you're using. All right, now we have to know how to convert. Please pay attention to this, okay? One full revolution could be represented as both 360 and 2 pi radians, which we just used, okay? So a couple things we have to know. If 360 equals 2 pi, then 180 equals pi. All you really did was divided by 2, okay, which would give you that. So this we should know, we have to know, so please make sure you know it. And now we're going to convert. Do not get these mixed up. I want to say this is probably the one thing that a lot of students flip the incorrect way. When you're going from degrees to radians, okay, it's going to be pi over 180. When you're going from radians to degrees, it's 180 over pi. Do not forget that. Okay, it matters how it's written or you're going to get the incorrect answer. If you flip it the wrong way and you're solving it, you should be able to kind of figure out, hey, it's not written correctly. Okay, my answer wouldn't be correct if I'm switching it from degrees to radians or radians to degrees. So let's go ahead and do some examples on the next slide and see what it's going to look like. So looking at these examples, you should be able to tell which one's in degrees and which one's in radians. Okay, super easy. We should be able to tell, but now you have to know the rule. Okay, I'm just going to write it. Again, the more you write it, the more you're going to remember it. If I'm going from degrees to radians, I'm multiplying by what? Is it pi over 180 or 180 over pi? It's going to be pi over 180. Keep in mind you're multiplying. If I'm going from radians to degrees, what am I multiplying by? 180 over pi. So you cannot forget that. Write it down somewhere every time you have to solve these, and you will remember it, please. Now, they're asking me to convert the angle from degrees to radians or vice versa. So let's look at number 11. What is this in? Degrees or radians? This is in degrees, okay? 150 degrees. So I'm going to convert it to radians. So I'm just going to go ahead and write that this is degrees. I'm going to have to convert it to radians. So what am I multiplying by here? Okay, pi over 180. Keeping this over 1. Now, a couple things you could do here. You could cross simplify if you can, which I know I can. Why? Because these both end in 0. I could cancel out my zeros for both of these because then I know 10 goes into both. So now I have 15 pi over 18. Again, you have to simplify your answer. Can this be simplified more? Yes, using what number?
3.
Good. I'm dividing top and bottom by 3. What would I get? 5 pi over 6 would be my answer. So look at it. I'm going from degrees to radians. 150 degrees is 5 pi over 6. Okay. Now looking at number 12. Is this in degrees or radians? This is in degrees. Okay. And then what am I multiplying by? Pi over 180. Now, can I simplify? Yes, because they both end in a 0, canceling those zeros out. Now I'm going to have 32 pi over 18. Can I simplify this? Yeah, using what number? I can use 2. They're both even. And I'm going to get 16 pi over 9. Can I simplify it even more? No, this will be it. You have to simplify your answers. Okay. Now, looking at 13. Is this in degrees or radians? Good. This is in radians. Okay. And now what am I multiplying for radians? Good. 180 over pi. Another way to think about it, if you wrote this the wrong way, you cannot cancel out your pi's. Okay, from pi's, from radians to degrees, you have to be able to cancel out that pi's because you want a whole number. So in this case, your pi's are going to cancel out. Can I cross simplify anything else? Yes, which numbers? Good, 180 and 6. And what would I change it to? 6 goes into 180 how many times? 30. So in this case, all you have to do is multiply 7 times 30. It definitely helps, and it gives you small numbers to cross simplify. And what's 7 times 30? 210. Okay, again, do not forget those degree signs. They are in degrees, so please make sure you have it there. Let's go ahead and look at number 14. Is this in degrees or radians? Good. Radians. So what am I multiplying by? 180 over pi. Do not forget that negative sign. What can I cancel out here? I could cancel out my pi's, but don't forget this sign. Can I simplify 4 and 180? Yeah, I can, using what number? 4. 4 goes into 180 how many times? 45. So all I have is negative 45 degrees, and that's my answer. Okay, so please make sure you know the difference between radians and degrees because you have to know the rules for them.